Okay, question 9. So we've got 3 cos theta plus 4 sin theta expressed in the form r cos brackets theta minus alpha. So it's a fairly standard method. I've basically got to go 3 cos theta minus alpha is the same as, and use the addition formula to expand it. So I've got r cos theta cos alpha plus r sin theta sin alpha. Now I'm noticing now to compare, I'm going to compare that with 3 cos theta, I'm going to compare that with 4 sin theta, because I've got common terms. So in other words, what's left? So r cos alpha must be equal to 3, and r sin alpha must be equal to 4. So putting those two together, I call them number 1 and number 2. First thing I'm noticing is if I divide one by the other, I get tan alpha. So I can easily find alpha. And this one is in degrees. So alpha is equal to the inverse tan of 4 over 3, which is 53.1 degrees. And then to get r, I'm using Pythagoras. So squaring the first equation, squaring the second one, and add them together. I got r squared cos squared alpha plus r squared sin squared alpha is 3 squared plus 4 squared. In other words, r squared equals 9 plus 4 squared. So 25, r is 5. 3, 4, 5 triangle. You might have noticed that right at the beginning. So now we've got the form. We've worked out r is 5. We've worked out alpha is 53.1. So we're in the correct form. r, 5 cos of theta minus 53.1 degrees. Okay, so we're just about to, for 9b, find the maximum value of the function 3 cos theta plus 4 sin theta. Now we've already evaluated that that's the same as 5 cos brackets theta minus 53.1 degrees, and that's got to be at its maximum. Now, being at its maximum, that occurs when the cos of an angle is equal to 1. So the cos of theta minus 53.1 degrees equals 1. And that occurs when, if you think about it, the inverse cos of 1 is either 0 or 360. So that means that theta minus 53.1 degrees is 0 or 360 degrees. So theta must be equal to 53.1 degrees at its smallest positive value. So, looking at 9 part C, we've got a real function now. We've got a modelling situation representing the temperature in a warehouse. And we've got the function f of t, the temperature is 10 plus 3 cos 15t plus 4 sin 15t. Notice the link between what we just worked out before and this function. So we've got theta represented by 15t now. And we found out earlier that 3 cos theta plus 4 sin theta is represented as 5 cos brackets theta minus 53.1. So we already know that our ft function is now 10 plus 5 cos of this function. So we're trying to find the minimum temperature and at what point this occurs. So this occurs when this cos function here is equal to minus 1. Because if you think about the cos graph, the minimum value of that will be minus 1. So f of t is therefore going to be 10 plus 5 times minus 1. In other words, 5 degrees. In part D of the question, we're looking to see the value of t when this minimum occurs. Or when this minimum occurs, theta minus 53.1 degrees has got to be at its minimum point. And this is when the actual angle is 180 degrees. So theta would be 180 degrees plus 53.1 degrees, which gives 233.1 degrees. Now we know that theta is the same as 15t because of that earlier representation there. So now we know that 15t equals 233.1 degrees. So T must be 233.1 degrees divided by 15. So 15.5 hours from midday. So make sure you put it back to context. Make sure you actually explain that T represents the time in hours from midday.